I would like to introduce our article, Advancing Sustainable Consumption Through Digital Innovation, a study on smart technologies and energy-efficient appliances. While previous research has analyzed the individual factors influencing sustainable consumption, there is a significant gap in understanding how advanced technologies such as artificial intelligence, blockchain, and augmented reality collectively influence consumer behavior in the appliance market. The results show that increased transparency, real-time feedback, and user-centric digital tools significantly improve consumer engagement with energy efficiency technologies. The research combines analysis of consumer buying patterns from 2021 with current digital trends and regulatory frameworks projected for 2025. Recent research highlights the need to assess the life cycle impacts of household appliances from raw material extraction to waste management. Understanding consumer behavior has become key to achieving real energy savings, as the differences between the theoretical efficiency of appliances and the actual performance of households are largely due to behavior. Blockchain technologies are being tested to ensure transparency in supply chains and offer information on the environmental performance of appliances. Energy efficiency is a key to reducing greenhouse gas emissions. Electricity consumption by household appliances is responsible for up to 17% of total CO2 emissions. The life cycle of electrical appliances has been divided into 4 phases: production, transport, use, and disposal. In each phase, consumer decisions affecting the negative environmental impact of electrical appliances were examined. A survey was conducted with 1,725 respondents. The questionnaire was divided into 8 sections, aimed not only at capturing current consumer purchasing behavior, but also at gaining insights relevant to the development of an environmentally conscious mobile app for decision support. Qualitative research was conducted through follow-up interviews with selected respondents. These interviews helped to uncover deeper motivations, knowledge gaps, and the barriers to interpreting energy labels. The data were analyzed using IBM SPSS Statistics version 26. The integration of quantitative and qualitative data served as a basis for outlining the logic, structure, and content of the prototype smartphone app. If retailers were required to disclose information on the distance products traveled from the manufacturer to the warehouse, consumers could make more informed environmental choices. This information could include a transport load factor, which would provide an approximate level of CO2 emissions depending on the distance and mode of transport. More than half, 54%, of appliances are purchased online, highlighting the importance of delivery methods in determining environmental impact. Parcel services are preferred, which means efficient delivery and minimizing emissions, while express carriers and personal pick-up by car, chosen by 89%, are the least environmentally friendly. Research shows that current energy labels are not fully effective. Most consumers cannot estimate annual running costs from the labels, but prefer to have this information displayed. Without understanding the link between energy consumption and costs, consumers may choose less efficient appliances because of uncertainty about the return on investment. 52% of respondents indicate they always use energy labels when making purchasing decisions. However, 27% of this group admit they cannot consistently calculate the approximate annual cost from the labels. 31% of respondents report using energy labels only sometimes. They tend to consult labels primarily for more expensive appliances, where potential energy savings might be more significant. 17% of respondents state they don't use energy labels at all. Their reasons include not understanding the information presented or simply not considering the labels important for their purchasing decisions. The Likert scale showed a key relationship between price and energy consumption. For 87% of respondents, price was equally or more important than consumption, which is consistent with previous findings that 42% of respondents are hesitant to purchase more expensive, energy-efficient appliances due to uncertainty about the return on investment. To encourage better choices, consumption should be reflected in product prices, possibly through excise duties or tax benefits for green products. Manufacturers should include innovative features such as self-optimization, energy monitoring, and modular design to facilitate repair. Disposal, the last stage of the life cycle, has a significant environmental impact. Appliances contain harmful substances and valuable recyclable materials such as gold, copper, and iron. The survey found that 24% of respondents are not aware of take-back programs and 17% are aware of them but do not participate. Better informing consumers about convenient take-back options, such as take-back shops, could increase participation. Increasing awareness of recycling and take-back options could significantly reduce the environmental impact of e-waste. In an age of widely available modern technology, it's possible to facilitate consumer decision-making when purchasing electrical appliances through an interactive app on smartphone. A survey of respondents showed that most were not well informed, didn't have access to information on the environmental impact of appliances, or didn't know where and how to look for it. For the application to work, it is necessary to create a central database into which manufacturers and carriers would scan the QR code of the product. Carriers would enter the type of transport used for a particular route. Consumers would have access to the database by scanning the QR code on the energy label. The user scans the code with the help of a smartphone, based on which information about a product is displayed. The app can use artificial intelligence to provide personalized recommendations. Based on the user's profile, appliance usage habits, and historical data, the system can suggest optimal energy savings devices with the shortest return on investment. This study highlights the growing importance of integrating new digital technologies, such as artificial intelligence, blockchain, augmented reality, and connected databases, into consumer decision-making tools. By analyzing purchasing behavior from 2021, and aligning the findings with the current digital advances and policy directions in 2025, the proposed application offers future-proof solutions to promote sustainability in the electrical appliance market. Future research should explore the long-term impact on digital tools on sustained energy efficiency improvements across different consumer demographics and regions, how behavioral interventions can be dynamically adapted using AI-based insights to increase their effectiveness over time should be explored.